Boa tarde a todos. Good afternoon. So we are going to start now the second talk of the series of talks related to industrial speakers. So this series of talks are promoted by IEEE Sequencing System Society, Chapter Rio Grande do Sul, and IEEE Council in EDA, Chapter Brazil, together with Federal University of Rio Grande do Sul, also with the support of Brazilian Computer Society, Brazilian Microelectronics Society, and the Brazilian Association for Semicondutors. And time so to have a good overview about the excellent work that is being done at HTMicron here in Brazil. So the talk will be done by Dr. Willyan Hasenkamp and Edelweis Ritt. And you have here in the flyer that was distributed a short CV of both. So both have done a PhD, Willyan in Lausanne and Edelweis in Germany. So I'm not going to take more time talking about their CVs, because the main reason for this talk now is to know more about the nice work being done at HTMicron. So I give the floor to Willyan and Edelweis to start the talk. So I will show here the slides of the talk, and then I'm giving the control of the slides to Willyan to start the presentation. Thank you very much for accepting our invitation.
Thank you very much, Ricardo, for the introduction. And
thank you, Ricardo, for having us.
Yes, we are very glad to be here. The idea is, Edelweis proposed this topic, and I think it's great because the idea is really to talk about the multi-component integrated circuits. And so the idea is here, forget the modules, go system in package, let's say, something like it. And HTMicron, we started to migrate and really go for it 2 years ago. And we just recently launched a new product in the market. So in 2 years, using this, we could come from a vague idea what could be done to a real product that is already in the market. So basically, the idea is really to discuss these opportunities and these possibilities and why we choose to go down this road. Otherwise, if you want to add something.
Yeah, that is exactly the idea. We believe that the market will go for SIPs, and SIP will play a very definitive and important role right now for IoT. And we will give the rationale here why we believe that SIPs or MCOs are the right solution for our next wave.
Yeah, so basically, as everybody knows, everybody's aware, everybody has been working for it since the last 40 years. So there was a transition from the discrete package to a very complex integrated circuit or the multi-chip solution. So basically on the PC, everybody was aware and everybody has only a single chip, but when the mobile came, and now we can see a lot is, for example, in the memory side, in HTMicron, we pile up 10 dies on top of each other just to make a single memory, which has flash memories and DDR memories all inside a single package. So with this new wave that it's believed that it's the IoT, we believe that could be very beneficial to develop new products with new things. So check what's the next slide.
The company.
Okay. So let's just talk about a little bit, just for you to know HTMicron. Maybe otherwise, if you want to
Yeah,
comment?
I can do it. Thank you. HTMicron was established December 2009. That means it's 10 years way. It started focusing on memories, and we served the waves that we showed before. We are working today. We will show in the next slide about our products, but we focus on PCs, and then we evolved to mobile markets, and now we are evolving again to serve the third wave. That means we are coming to IoT. And the vision is to become the leading semiconductor company and the core of electronics value chain in Brazil. Whatever I have to say, we expanded our vision for a more global one this year with the launch of our product. We will talk a little bit more later. And our mission is to add value to the Brazilian semiconductor industry. And we have a customer focus quality. We have very good quality, and that's what guaranteed us a very good position at the memory PC, TV, and computer so far. Mobile. We also have a very good teamwork, a very diverse teamwork. We are a great place to work, a company, and we promote a lot of ownership, and we are very sustainable in terms of environment and also in financial terms. Today we employ circa 300 people in São Leopoldo, very close to the university called Unicinos, inside of the Unicinos campus. And our main shareholders are the Korean company called HTMicron, the FINAP, that's the Brazil project agency, for Brazil for funding projects. And we have also some Brazilian shareholders. Yeah, about our partners, we started partner for the PC, smart TV, and smartphone memory products. We are very well established, and today we are serving all major players in the local market. And then we started moving for IoT 2 years ago. Me and Willyan, we are hired to do this change, to bring this other evolution inside of HT. And in this regard, we just developed a product. We will talk more later. And our big partner in this is ST Microelectronics. The partners is also the ministry. Government is a very good partner. FINAP is a government agency. They are our shareholders. And we have a lot of local customers, but also a lot of global customers. This is a very big change for us. I mean, with this product, HTMicron is committed now to evolve for a global company, not more serving only the local market, but doing innovative products that have value in the whole world. Willyan, you want to talk about this?
Yeah, okay. So just about a little bit of the history. Yeah, of course, it was established in 2009. The JV, the joint venture between the Koreans and the Brazilians. And then, of course, there is a long way when these things start. And everything also was settled up during this phase to happen inside Unicinos. So Unicinos University was a big partner for the establishment of HTMicron. And then it was natural that it evolved into the phase one, which was the base camp. So basically there in the base camp, started the production of the smart chip, the one that should go in the credit cards and this kind of things. And then this, there was a long way as well until the building was ready to start the manufacturing. So when the building was ready about 2014, and then it was when it started the new products like the memory ones with the DDR3, and go into a phase where into the PC markets for maybe 2. I mean, it's still here. We still sell the memories, DDR3 and DDR4 for some markets, but then new products came in where it started phase 3 with the mobile phones and the more complex and challenging packages, which is the EMCP, which is the common package for the mobile memories, where you have really to pile up of several dies and use different kinds of technology. And then in 2019, we start with the phase 4, which would be going to this IoT. Here, really, the idea is let's leverage what HTMicron has learned during this year, during these very long years, and what is available already in the factory, and what can be done with what we have, and how we could position ourselves differently in the market, and really bring new, different solutions to this market. And that's where the HT32SX was thought and developed. So basically, and of course, there is a lot of people around. Fortunately, here in Rio Grande do Sul, we are very fortunate to have the CI Brazil program for very long years, URGS, PUC University and Unicinos University. So big universities in Brazil that provides a lot of great people. So we have a lot of know-how and a lot of knowledge here. So that's why it's possible to do these things nowadays here. Not only the factor, but the human capital here is very important as well.
And it's important to say that 10 years history from scratch to a very financially sound company having more than 100 million US dollar revenue. This is a big achievement from the people. Also in the past, we are the last 2 years there, but there's a long way and a lot of people that did a very good job.
Perfect. So the next slide, the idea is really to talk about, I know everybody knows you are from the field, from the semiconductor field, but just for you to understand how packaging is, we will be very short. So semiconductor packaging history, basically everybody knows and everybody deals with the inline packages. So the dip, and then they came from the new ones, and the ones that currently it's very popular and very cheap with it, which is the QFP, QFN, and other ones that are very similar to it. And then afterwards in the 90s, where the BGAs were introduced. So in the BGAs, you don't have the lead frame anymore. You start to use a substrate that gives you a lot of flexibility, and also the variation of the QFP, the QFN came in the 90s. In the year 2000, then is where this kind of integration or combining different stuff into the single package came along, which is the system in package, the package on package, and then it starts to come close to the front end fabrication, and really, you know, when you do the back end of the chip, already use the line to do more fine things using the technology that's used for making the chips. And then the wafer level package came out, and then the 2.5D, the 3D integration, and a lot of technologies currently being developed in this packaging field. So
one more comment, I think it's very important to say, because some people used to think about packaging as a very simple technology. It's not this way anymore. You are adding more complexity or more complicated processes coming to the wafer level. It's very important to know that it's very complex. It's possible to do very complex things in packaging.
Yeah, and although it's not very easy to simulate and to define things, you know, at this level, some things, the process variability is very big compared to the silicon die. So there is a lot of efforts that needs to be done, and a lot of things that are needed for this to succeed. So there is really things that make our hair white in this field. Basically, what came out is that you can resume that nowadays there are basically 3 types of packaging. So we have, when you discuss about it, you really don't have much to choose. You can go lead frame. Everybody knows, everybody uses it. A single die, go there. Maybe some multi-die as well is available, but basically you have a lead frame. You have the wafer level packages where you can go fan in or fan out and really have redistribution layers, and this is what you do very much closer to the, let's say, to the back end, or when you are in the wafer fab. And then you have the substrate based packaging where you have a lot of diversity, I would say, several categories with ceramics, organic laminates, and whatever you think you can thought of. So CMOS image sensors, multi-chip modules, BGAs, 3D, 2.5D, flip chip, and basically these multi-component semiconductors as well. So there is a lot of things that can be done in this substrate-based packaging, and that's actually where HTMicron can end its position. So really what we can do in our factory is really substrate-based packaging. The other ones are really far away. So basically, in-house we have a lot of this packaging process that goes from the wafer thinning to the dicing, to the die attach, wire bonding, molding, laser marking, ball mount, and sawing sorting. And then you have also the test side, which is very costly, and the equipment is very expensive, especially on the memory side. And then you have the DC test, burn-in, core test, speed test, visual inspection, then up to the packing where you can ship to the customer. So
I think one more comment is also, if you are in the packaging industry, it's not the case that you don't have to invest a lot, especially if you are in mobile. We have changes in technology very, very quick, and it is a very capital intensive also what you do. Not so much like a wafer fab, but there is a lot of investment that have to be done in order to maintain the products.
Yeah, even in the wire bond, it's amazing. I mean, the balls, you do the ball and wedge bonding. When you do the ball is even smaller. The wire is smaller, so you need a smaller capillary. You need the small trails. It's a very complicated process. You have a small window to operate. There is a lot of processing going on in the manufacturing level, and we have fantastic people in HTMicron that has been working for a very long time there, and the engineers there learn a lot. And I can say that we can develop some packages ourselves nowadays. So that's why we are doing it, because we don't need really to copy from anybody. We can do by our own, which is really great. And that's why we came to this forget modules and then really let's go SIP. Let's do something with what we have. Edelweis.
Yeah, I think it's very important to say that there is an old way to think that SIPs are expensive or they are not competitive on the market. It is possible that during a certain years ago it was the case, but today we see a lot of products that are launched especially for SIPs and being SIPs as an alternative, and we will defend why we think that this technology is the right one for IoT. I mean, you had the idea of the chip, that you had developing the wafer and the chip design, and then you took this chip and you packaged and you put in the board and you did the system in a board. And then you started doing some systems directly on the chip. And there is also the possibility to do in the package. And why we think this is the right solution, the complex chip, the system totally in package, we will detail a little bit more.
Yeah, so just to come along, as everybody knows, and they are able to design the board, it's very common. and everybody designs the chip. But nowadays there are so many technologies to make different stuff. Where you do memories, you don't do processors, or you don't do any MEMS, you don't do any sensors. So how you can really combine it? I mean, we are engineers, so we should find an optimal equilibrium point. Just don't do it's not. We don't necessarily need to use a technology that is not needed for that. You know, you don't want to use a 5 nanometers technology to build a sensor that you can build with 1 micron technology. So why? And you can really integrate it, everything, and you need to pile up the dies on the package, like you can see in the middle. So, and you don't need to have the component. You can really have the die and design it as a chip. And with that, you can really combine several stuff inside. So we believe that there are some technological approaches that in this design, in this electronic system, and how we do integration basically on the chip, the more and more, or the SoC in a component, or more than more with the analog and the high power and sensors and whatever. And in the package, where it comes the multi-component semiconductors and what is also called heterogeneous integration. And then basically there you can have the basically 2 technology, the wafer level package and the substrate board and module level integration.
The ITRS, they already defined this idea of combining SoCs and SIPs in higher volume systems as a different, let's say, dimension to think about. Because you can have the best of the Moore and the best of the Moore and combine both in a system and package. And that is the beauty of the solution.
So we are not doing anything new. We are just doing what we have in our hands to play, and really we are coming. The IoT market, it's all about making things smaller, because you don't want to have a module like this one. You can see like a Raspberry Pi. It's a credit card size, okay, but it's too big for an IoT product. Maybe an IoT product is just like a button. You just want a button to work and to move around and to do some stuff. So you or even the Apple Watch, they could not build the Apple Watch with the module. So and also sometimes if you want to design a die, the non-recurring engineer is too big. If you go to very small nodes, the masks are too expensive. So no one will solve the problem. And then really we could do it with the system in package, with the multi-component semiconductors. We can design. Yeah.
Between the size and the performance and the cost of a single monolithic chip.
Yeah, exactly. So we can have a faster time to market. We can reduce the investment needed to develop the product. Of course, maybe if it's scaled up, maybe you can think about integrating it into an SoC down the road. But you can really have high volume and massive products going to the market with this kind of approach in a much smaller form factor with a very cost-effective solution. So that's why we decided to go this way. So basically, you can punch everything you can think of inside this substrate. You know, it's like design a board, but in a smaller level, and of course you have some other things to think about, because you want to mold it afterwards, and you want to protect, or you can isolate some layers. You know, nowadays they even use the wire bonding to do shielding inside the chip. So you can have a die, and then you can just do some wire bonding on top of that die, and then you protect that shield, and with that you can have a moving band RF inside. You're going to have an antenna in the package, SMT, flexible stuff, photonics stuff. You know, you can have flip chip, you can have shielding, a lot of things you can do inside the package. You can really build very complicated and complex systems using this kind of technology. So, and it's available here in Brazil. So imagine that, you know.
Yeah, I think one more thing that's very important about this is that we have a lot of challenges and advantages. But I think before we go in details, I think the macro idea is that we package the complexity of the chip inside of a package, so that the customers that will use, and especially in IoT, that are not specialized in technology, sometimes are other companies putting this technology, bringing this for products that didn't used to be connected or different. They have technology for the products, but they don't have experience with connectivity and this kind of product. If you can package the complexity and give something that is easy to use, this is our main vision. We'll talk a little bit more about this.
Perfect. I mean, we can do a parallel with like the computer languages. We have assembly in the past, and it takes too long. It's too complicated. Then came C language, which facilitates a lot of things. Of course, there are some drawbacks and some advantages of using one and another, but I mean, it's just a level of abstraction. And now, when you go into IoT, there is a lot of ideas and a lot of things that people want to do. And how can you remove a lot of challenges that the people will face and just give them some, you know, a closer time to market for their products? I mean, let's just simplify the things. It's all about engineer. We are engineers. We always want to, I mean, we complicated things several times, but we are always trying to simplify it afterwards and develop the technology to simplify things for the people to make the world. You know, we want, without engineers, there is no world like we know. So really, with this, there is a lot of challenges with this integration, and this next generation of products will demand from the component to the system, performance, ultra low power, you know, long battery life, faster products introduction. So, for example, even to us, we developed the IMCP32SX, which is an IoT product for the Sigfox, and we probably will do something else. There is another product down the road that will improve the current one in a much faster and really almost continuously, because we have the version, for example, we have the version 1, we certify, but we even have not put it in the market, and then came the version 2, which is already coming to the market. So the cycles are much smaller, and there is a lot of opportunities with new things, with a lot of computing stuff coming together, a lot of different architectures, and you could think of integrating these different architectures. So there's a lot of machine learning and of course, like brain chips or things like that. How can you mix those stuff? You could do it in a set. So really, we really believe that depending on the application, depending on what you want to do, the multi-component semiconductor, the system in packages, is a really, really good solution to go for.
Oh, we should not have brands. Sorry, but the idea is that we don't. Sorry for this. The idea is that we believe that system or module can be substituted by a system in package in a very quick way, have a lot of advantages. Yeah, let's talk about the advantages. The MCLs, they are thinner, smaller form factor. We have increased performance and we have a lot of integration. You can put a lot of different heterogeneous functions, like we said before. We have a lot of flexibility for manufacture, for design. You can do 2 variations, for example. You mount a certain thing or you don't mount. You can also develop a certain wafer that you can use in different MCOs to do the volume. I mean, to reuse the silicon, monolithic silicon in different variations. We have a better electromagnetic interference isolation. We have a reduced system board space and complexity because you have a smaller form factor. The power management is a lot improved. We have more room for battery inside of the final product. The SMT assembly process is simplified. To have an idea, we have more than 50 different little components inside, and now you have just one component to solve in your board. The NRE is lower because the whole complexity to put this 50 little chips to work together was done by our engineers. That is complexity that you have to care about. And the idea is to have a one-stop turnkey solution from the wafer to fully tested MCUs.
Yeah, and if you really think about it, if you are in the SoC, you are still playing planner. You know, it's still the transistors are next to each other. Of course, you have the 3D transistor for memories now and things like that. But really, you want to do things, you are playing planner. And if you go to the board, you don't put components on top of each other. You are still playing planner. So in the MCO, we can really pile things up. We can put a die on top of another die, on top of another die, on top of another die. You can really go into another dimension and really make really nice things and small things. So we believe it fits particularly well for very specific solutions, even, you know, awkward environments. For example, automotive electronics is awkward, you know, there is a lot of demands. And you can fit from a lot of lot sizes, from large sizes, medium, and even smaller sizes. So which is not available with the SoC. For example, you really need to target a very large lot size, otherwise your project will not pay off. And so it's really, really competitive. You can think about multiple active or passive dies, stack them up, and really it accelerates a lot your time to market and the development time. Also, with that, we believe it lowers the development risk because you do it faster, you interact faster, you go to the market faster. If you fail fast, and then you can do it again. You don't have to wait a lot of time to see if your product will really come along. So, and really, we take advantage of the existing infrastructure. You don't need to build new factories. Of course, there is new equipment for new packaging technologies, but not very expensive like in the front-end industry. So it's really very cost-effective plug-and-play solutions that you can build with. So that's why we decided to go this way. Maybe the device?
Yeah, maybe about applications. I think it's really a myriad of applications that you can use for applying MCOs. Obviously, we have to do a thorough evaluation to see if the product is able to be done in this way or not. We always do a kind of evaluation before we start doing a project, but there is, I would say, almost all markets, it's possible to have some applications that are more effective to using multi-components instead of specific solutions. We are a partner for packaging, not only our own products, but also for products for customers or partners. And I think it's very important to say if someone has interest in doing a project together, we are open for talking about other markets. We are not, let's say, focusing only on the markets we listed here. We are a packaging company at the end. And if it's a multi-component, we would evaluate for sure if we are the right partner to design. And we invest together. We put our NRE to design together with our partners. We are a good partner in this case. We are not just a service provider. We work as a partner.
Exactly. That's why we try to do by ourselves a new chip, but you can count on us to develop your product if you want to do something in this direction, and if you believe you can integrate some SoCs or develop a new product. For a lot of examples you can see in the market that uses these technologies, just here, 2 examples, one at Broadcom, another one from Corvo. If you just remove the packaging, you look inside iPhone 7 or even iPhone XR, you will see it. They all use the system in package. A lot of dies, a lot of sensors, a lot of filters, wire bonding, a lot of different things, passive components inside. So it's really, you can really build very complicated, and it's in the market. So all the big packaging do it.
This is just as examples we put from internet. They are not done by us, but it is an example of people using MCOs. And that's
exactly. So there is a workflow that we usually follow. This is very, very traditional. Just for you to have an idea, you know, specification, design, package design, and a lot of interactions process, and then you go to qualification until you have your product. And then basically it's the same cycle everybody knows. When you do the SoC, and in the SAP is no difference, just a different animal, I would say. You design the package, the substrate, and you have a die, do the interconnections, routing, and you simulate to see everything's going on. So basically, we implement all this process flow. There is a lot of opportunities in this direction. So why we decided to go this way, when you look to the semiconductor industry, basically there are 4 main driving forces nowadays, which is the front-end limit. So you always push to the smaller node, and it's becoming very, very difficult and expensive. So just a few players in the market that can do really things at this level. And then you have the back-end dominance with new packaging technologies coming into focus, the IoT and the system, and the increasing complexity of the systems that you try to develop. So HTMicron was really well positioned to play in this when you look at it, because we have the back end, we know how to do it, we have a lot of complicated technologies to do the package. There is the IoT where we can play, and we can reduce the complexity. And afterwards, our idea when we start to develop the new product was really how we could offer the best customer experience possible with the chip that we did. So that's what was basically the idea behind. Of course, IoT will be a big market, a lot of demands, a lot of growth in several segments, from the automotive to the industrial, the processing, communications. Well, you just have 5G coming along. There is no 5G without SAP. And then, of course, we have some R&D strategy. We decided, okay, there are some things where we want to play ourselves. Let's see how this will come along. They are not separate. They are all together in the same bucket. And we need partners. We need the partnerships all along. But basically, the idea, okay, let's do some IoT, maybe move into 5G, AI, automotive, and then there's a lot of things that we can do and develop and play inside this.
Yeah, I think before you start this, just to say, I think there is a lot of possibilities in markets, but the idea is we are looking at the trends, and we are committed to be a global, to do products that are do play in the global market. It was a very good time having some years working in the local industry, but now it is time to expand and to go global. That's
yeah, we can really play global. I mean, having access to the Brazilian market is great, of course, but it's afterwards only 2% of the worldwide market. So why should we limit ourselves to play here? It's nonsense. So let's really do partnerships and establish and find good partners worldwide, and then we can play worldwide. So when you look at it, to the packaging side, to the market side, when you look, there is really a lot of possibilities. There's a lot of, like, these points when you see in the image. So the idea is, okay, what can I do with all these points? It's really how you connect the dots. So if you start to connect the dots, you start to think about it, maybe there is an animal there, there is a value in the market. So basically, that was the idea behind.
I think it's important to say that partnerships is very important. Semiconductor companies are very some in the world, but no one can play alone. I cannot start reinventing the wheel every time. It takes a lot of time. I mean, I think the success of what we did here is related to our partnerships. ST, for example, was key for us because they have a very good chip, and they helped a lot. And also WND, that is the company that put the infrastructure for Sigfox in Brazil. Also, we have to say the Sigfox themselves, they helped a lot. All these things are connecting dots. It's the idea to put something together with a lot of partners to have something that's good for everyone.
Yeah, and then with that all those things in mind, and look to HT, and then that's why we did the first no-memory product of HTMicron during these years, and we call it IMCP HT32SX, which stands for a Sigfox product. It's unique in the market in the Sigfox market. There is no one like it. So, and it's what they call Monarch. So it can do the automatically roaming all the regions of Sigfox around the world. So no need for, you have a device that was designed for the American market. And how can you play in Europe? How can you go to Australia? How can you go to Japan? So would you need another part number, another module? We thought, okay, let's remove these barriers. Let's do something that you can move around, or if you want to deploy your project, whatever there is Sigfox available, our chip is the solution.
Especially so really, for chips that are in global solutions that are moving, that are exchanging, like you put in a package or a pallet, or in a ship that is traveling from Brazil to Africa, for example. If you have things moving, you have to be mobile. This is the idea.
Yeah, so basically to do all this, there is no other way. We need to go with the multi-component integrated circuit. And really, the idea here of this chip was really to have an all-in-one connectivity solution for the IoT, for the Sigfox network. We cannot play with other networks now. We have other products that will come, but we decided to go this way, really to have an advantage, because we saw there was a space in the market for that. Is actually the first, we believe, to be the first Brazilian IoT chip, which was totally developed here in Brazil, and it's totally produced here in Brazil as well. So we all talk Portuguese as well, of course, which is great for the local market, because with 2% of the markets, nobody else in the world has very much interest in here. The volumes are not high, but we can really do really good product. The idea here of this chip was really to provide an out-of-the-box IoT experience for developers. So you just get a chip, you connect the battery, you connect the antenna to the pin, and you can already have a package delivered to the cloud. Really, imagine, now you could go from the idea of having something into the cloud and prototype your product maybe in 1 day. That was our vision, that was our dream for this product. And we are almost there. We have some clients that just reported that it could come from the idea to the prototype in 3 days, which is really amazing. So our code, for example, for developing these things, we have a lot of things done already, and it's freely available on GitHub. So you can reuse a lot of the code. You can use a lot of examples. So the idea is really to have a community involved in this and develop the new things for this chip, or even help in redesign it if you need it. So really, that was the idea behind this product. And
I think
I need to say
one more detail about the idea of the chip. We believe IoT didn't get now to mass deployment. We saw every day, okay, 800K gas monitor in Japan, or I don't know, it's starting. And for start, it's fully okay to use some big board and Arduino, or I don't know what, to start playing. But in the moment that you go in volume, that you really want to scale, you need something little and very, very good in price and in performance. And this is what we focus to have this product.
Yeah, and I want to say that really we have a lot of engineers that came from the CI Brazil program. I mean, probably all of them that are working, and I really want to thank all the people involved in this project, from the engineering side, from the processing side, and our R&D engineers are really great. You know, we did all of this with very, very few people. Very, very few people, and we could do it. So a lot of challenges. It took us a long time. We are really learning, but I mean, yesterday we got a message from the Sigfox guy, from the Sigfox guys. They just got our product, and he was reporting, oh, I'm so glad because I'm inside a lot of concrete and I can still really reach the antenna, which is 3 miles away, with a very good signal performance compared to any other modules. And I could just do it, you know, it's great out of the box experience. I just open up, plug it in, connect, and I can send a signal to Sigfox. It was not possible. Now we can really do things. So
do you know where this was? Where in the world? Where?
It was in the United States.
Okay.
Yeah. So really, as you can see, the chip has a lot of design flow. I mean, it's complicated to manufacture, but just for you to have an idea what we have in-house, a lot of things, we receive a lot of materials, and everything is inside our factory.
Yeah, we are over the time.
Yeah. We are finishing up. So basically, that's our last slide, just for you to know that we will probably be going into this low power wide area network scenario. So we want to go into there. We will go either as HD or with partners, or we definitely want partners. That would help a lot. So we developed the Sigfox, and now we are doing things for other technologies as well. So it's good that you know.
have the vision to be leaders in low power area, wide area networks. This is the vision of HT, is to be one of the biggest players in LP1 network products.
Exactly. So yeah, thank you very much, guys. Nice talking to you. If you have questions now.
So thank you again, Edelweis and Willyan, for this nice talk. So we have here some questions. So Fulvio Eilert, what are the challenges for production test of the MCO with dies from different manufacturers?
Yeah, great question, actually. Yeah, this gives a lot of headaches, and that's why we need really good partners. So, especially in the on the supplier side. So, for example, that's why we decided to, and we partner with ST Microelectronics, because it's really they are open to help us with this kind of tests. Of course.
Yeah,
Yes.
important to say we received the tested dies now. We have to test the integration.
Exactly. So the idea here is that we go for known good dies. So we know that the die is good, and from that on, we need to work on the system level and test the system to see if it provides the good feedback to us. We can develop the test ourselves. That's what we did for the IMCP as well. So.
Another question from RFIDO Design from Minas Gerais. So HTMicron intends to create a spin-off for that new business unit, like ASE did creating ASI, or do you think you'll be able to manufacture, develop new products, and provide after-sales support?
What we can need, obviously, is maybe a new factory, but obviously, I don't think we will separate that. I think it is very, I would say, a good synergy from packaging memories. I think we have this possibility to do because we package the memories. I think the two businesses are so entangled. I cannot see this.
Okay, another question by Gabriel Aires. Here you talk about CI Brazil. Now that the program is no more, how is HTMicron recruiting new professionals?
Yeah, we are in hard times now. Huh? Yeah, it's such a, it's such unfortunate that this program, which was really, really important to Brazil, was over. It will give us a hard time.
Yep. It's a pity, really a pity.
I can also do a comment on this. It's really pity all what we are facing these days, but I think we should have some waiting to things will be better in the near future, no? So I think we can expect that all these programs can restart if you have a new federal government situation in the near future, no? So this is one point. Another one, I think we can try to set up something similar, but maybe without all this scholarship, or maybe some scholarship from industry to do something more or less similar. That was the training center that was available here at UFRGS. But also we have the possibility to increase the number of, let's say, master and PhD students that also are very important nowadays, no?
Yeah, sure. Yeah, we need to work on it, and really.
I was at the committee of the IC Brazil for a long time. I saw a lot of difficulties, and I'm always optimistic. Let's see what the next year brings us, or the next 2 years. Maybe we'll be positively surprised.
Yeah. So another question from Paulo César Comaceto from Unipampa. Thanks for the nice talk. How about HTMicron and Brazilian universities interaction? May you provide packaging or COB for ICs design at the Brazilian universities?
Yeah, the interaction, I might say nowadays, it's still very poor. It's just the relationship that we have with other professors. I mean, they were my professors as well. and so people that we know and we learn from. And but what I can say for the packaging or for the IC design, please talk to ITT Chip at Unicinos. There is a lot of equipment, and we do a lot of support over there. There is a lot of course, Unicinos helped a lot. HTMicron. It's important for everybody to understand. Unicinos helped a lot HTMicron. So there is let's say our partner is Unicinos. We have a commitment for a very long-term commitment to them. That's why most of the things we did in partnership with ITT.
We are in the campus. Yeah.
Yeah, and we are in the campus, but it's very important that you know, I mean, ITT Chip is open to everybody. Everybody is very welcome. A lot of people from URGS already went there and did the wire bonding for their chips. I know, I mean, there is a lot of great equipment there that you are freely available and you can use. And, you know, talk to us, let us know. We will do the introductions for you as well. We can do this kind of matchmaking.
Yeah, we are commercial. We need to produce in volume, but Unicinos is the right partner to do this.
Okay, so I have no more question here. If there is still somebody willing to do question, must be done now. And so maybe just to finish, can you give some words about future directions of HTMicron? I know that maybe some of them you cannot talk now, but maybe some ones, yes.
I think we said a lot. We said there is definitely strategy to go global. I think this is very important information. I think at the end, Willyan showed also our roadmap about very different technologies of LP1. And like I said, the vision of our CEO is to be one of the leaders in LP1 semiconductors. Willyan?
Yes, basically that's the idea. I think, I mean, of course, there is a lot of we have a lot of challenges to develop the SIPs. Maybe we can do something together with the R&D community in Brazil, with other universities. Just think about the problems that we are facing at the packaging level, and then maybe everybody can help to solve. We have a huge problem on for example, on the substrate side. When things go from 1 micron to 10 micron, there is no solution so far to come with a cheap substrate, for example. So we have a lot of circuitry necessary in the IoT products, especially in the RF dimension. So there is a lot of things that could be done and developed here in Brazil that we could discuss. Anyway, we are open to it, but most of the idea to go in the next period is already set. And also, Jacobus made a question.
Yes.
I can see here.
So Jacob is asking if how COVID-19 is affecting the production.
Hi, Professor Jacobus. Thank you for the question.
Yes, thank you very much.
We had we saw obviously a change in the market, because we are mainly today focused on our current products. PC had a good demand because of home office, but mobile we saw some retraction on the market. But about the production, we could continue production in São Leopoldo. São Leopoldo was never closed. What we did is to make the measures that are defined by law, by decree from our major. That means maintaining 2-meter distance. We changed our layout. We put some people in home office, but we were able to continue operating in a safe environment. With some measures.
Yeah, fortunately, we are still into the semiconductor, so a lot of things are done by the equipment, so there is no need for many operators. So there is not many people in the factory anyway.
We can keep distance, yeah, that's good.
There is no more questions for today, so thank you very much, Edelweis and Willyan, for this nice talk.
No, so thank you for watching.
Thank you very much.
Thank you for having us.
So,
Good.
muito obrigado.
Perfect. Thank you very much.